Good morning, everyone, and welcome to this webinar. I am Ruggero Poletto, and I am speaking on behalf of Conself. We are a company actually very active in software development. Our mission is to help and innovate small, medium enterprises and freelancers improve engineering design of their products. In other words, we provide software useful to designers and engineers and should help them matching their needs. Our services include a CFD software available on cloud, CFD consulting activities in which we do design for customers, and support activities both on CFD software usage and on consulting and designing techniques. We also organize events such as this one, in which we try to increase and make more popular the usage of such type of instruments. And we also offer training both on site and remote, in particular for our CFD application. Let's get more into the topic of this webinar, which is the CFD of turbomachinery, in particular for hydraulic pumps. As most of you may already know, currently the European Commission released most regulations that has the only goal to increase the efficiency of most of the products we produce. In particular, I'm speaking about the 327 of 2011 for fans and the 547 of 2012 for water pumps. With these two regulations, the European Commission forces pumps and fans manufacturer, and in general, turbomachinery manufacturer, to achieve higher and higher efficiency for their products. The most recent efficiency target was set in January 2015, so January this year, and forced once again all the manufacturer to improve their product efficiencies. Getting into more details of such regulations, we can have a quick overview of the ERP regulation for fans. This applies to most of the industrial fans, and there are exceptions just for special fans, such as ATEX fans or high temperature fans used for emergencies only. There are also exceptions for fans with small power, and moving forward, we can have a very quick overview on how this regulation works. It basically defines a target efficiency every fan has to achieve, has to reach. This target efficiency depends on many parameters, such as fan type, like forward curve fan, backward curve fan, axial fans, or measurement type defined in order to get the calculate the target efficiency, like we are measuring static pressure, like type A, or total pressure, type D. Another important parameter in order to calculate this target efficiency is the absorbed power. We can see there are several formulas, each of which depends on the power, absorbed power of the fan. And obviously, there are coefficients also to take into account the fan drive typology, such as direct drive or belt drive fans. A similar regulation works for the hydraulic pumps. In here, the main difference regards the application, not only at the best efficiency point, but also the regulation specifies a target efficiency at 75% in volume flow of the best efficiency point and 110% in volume flow of the best efficiency point. In this way, we don't define just a single point, but we are here. This regulation defines let's say, a small curve on which the the efficiency calculated from the experiments of our product must be above this limit. Why should we use CFD? Well, most of us knows that CFD means computational fluid dynamics. In other words, CFD stands for a virtual laboratory where it is possible to run tests. And by tests, I mean measure quantities and performances of our products, such as pumps. And since we are working with a virtual laboratory, we are testing our pumps when there is no prototype yet. So the only thing we need is a CAD file, a 3D model file that can be designed with most of the CAD software currently used by industries. By using CFD software, we can estimate performances such as efficiency, absorbed power, or prevalence of our pump. But not only this, we can also use more advanced technique in order to calculate the noise levels, and also in some cases, it is possible to calculate the erosion that in particular is due to particles immersed in water. What are the most important parameters? What do we have to care in order to run correctly a CFD simulation? Well, it is very important to take care about the flow models, to think whether we have to deal with water or air. This influences whether we have to choose an incompressible flow model for water or compressible flow model for air. It is also important to think about the parameters of the fluid, such as the density, the viscosity, the heat capacities, and so on and so forth. Finally, it's important to take care about turbulence. This turbulence is a mathematical parameter which is very important because it highly affects the separation zone we are going to see later on. This separation zone, anyway, affects the performances of the pump and also may lead to some effects such as cavitation. It is also important to note that in most common software, we are asked to specify or to identify two main parameters, two main turbulence parameters, such the turbulence intensity, which we suggest to maintain between 5 and 10%, and also the hydraulic diameter, which is specified by 4 times the area of the section divided by the perimeter. Boundary conditions are fundamental because by applying them, we are able to specify whether we want an inlet for velocity or at which pressure we are working, or it is also here important to specify the turbulence parameters, such as K, epsilon, omega, or nu t. In here, we provide a brief summary of the most common boundary condition, in particular for pump simulations. We are here just to mention that it's worthwhile thinking about the inlet as a velocity fixed value in which we force a certain velocity to go through the pump. And at this very location, it is also possible to define K, epsilon, omega, and nu t according to the formula we provide here. Once again, we see here how to apply the turbulence intensity and the hydraulic diameter we saw earlier. It is also important to define the outlet, and we suggest to define it as a fixed value for pressure, like environmental pressure, and to specify fixed gradient for all the other value with a zero gradient, basically, condition. And last but not least, the adiabatic wall, which is another type of boundary condition, very, very useful in case of pump simulation. It's worthwhile mentioning that this table, together with the materials we're going to see later also during the presentation, is currently available at the website wiki.conself.com. Another very important phase of the simulation is the mesh specification. In particular, there is a Y+ parameter, which is very, very useful in order to understand whether the mesh has a good wall resolution. So whether it's possible to actually capture the velocity gradient close to the wall. In general, we suggest to maintain this parameter between 30 and 300. This parameter is affected by the mesh size close to the wall, and we'll see later how it's possible to select this size, but also by the fluid type, such as the velocity and the fluid viscosity. So, given a certain mesh size at the wall, it is possible to have different level of Y+ according to the velocity, or also if we consider two different flows, one, for instance, with water and one with a certain type of oil. From now on, we are going to see a couple of examples taken from the website you can see in this slide. In here, we have a particular pump we studied, and it's possible to see how we studied the influence of the splitter blade, which is the shorter blade. We took 3 different lengths of this blade, and we calculate the pressure difference between the inlet and the outlet of the pump. And obviously, it is possible with CFD to take the most efficient solution among the 3 we studied. In this slide, we are going to talk about wall shear stress, which is a parameter that defines the friction close to the wall, and this parameter is fundamental once again, since it's a way we can study the flow detachment from the wall. By flow detachment, I mean a phenomenon which separates the main flow from the walls and creates a lot of turbulence, in particular vortices. There is a coefficient named friction coefficient and defined as the wall shear stress divided by rho and u squared divided by 2. And by having a look at this coefficient development along the blade, it's possible to detect whether we are in case of a separated flow or not. It is important during the designing phase to minimize the separation zones by modifying the geometry of the CAD, of the blade, of the pump in general, also because having huge separated flow may also occur into cavitation phenomena. We are going to now see a small video we did during another job in which we are going to have a look at the erosion study. In this particular case, we studied first of all the flow. Here it is the flow contour plot of the velocity magnitude, and then we injected into this particular valve some particles. These were basically sand dissolved in the fluid. Once again, it is possible to note that the sand was moving from the left-hand side to the right-hand side of this particular cyclotron, and this leading to a strong collision with the walls of the cyclotron, and thus abrasion phenomena. So we were asked to estimate the erosion in order to estimate the life expectancy of this particular product. Another simulation that can be done, just 1 second, I'm moving to the next slide. Another process we developed is the optimization process. Everything starts with a parametric CAD in which we by acting on several parameters defined in the CAD phase, such as blade curvature or pump diameters or some others, it is possible to obtain a parametric CAD. In this way, and by using a lot of CFD and numerical simulation, we are able to analyze a very high number of results and thus obtaining the optimal solution to your problem. Obviously, we talked earlier about ERP regulation, and thus, according to that, we need to measure the overall product efficiency, but we can also study the noise levels and the fluid structure interactions, and thus check whether there is vibration problems or something like that. It is also worthwhile mentioning a couple of advantages of the CFD simulations compared to standard experiments in labs. In general, they are much cheaper than experiments because we don't need prototypes, we just need a CAD model, and they are much more quicker because they can be done in a few seconds. Also by using Conself CFD application we're going to see in the next slide. The main disadvantages may come from the accuracy. The CFD user needs to be quite expert into running the simulation. And once again, Conself helps users in setting up the correct simulation, as we're going to see from now on. This is the presentation of the Conself products, which said is a CFD software available on cloud, and thus we got rid of most of license costs and hardware requirements, and we allow users to save up to 90% compared to standard software costs. We define four main phases of CFD simulations. One is the CAD model, then there is the definition of a geometrical grid or mesh, and there is the CFD setup process, and then result analysis. Most of these steps we saw briefly earlier, but we're now going to see how they are going to technically work. In the CAD interface, it's possible to use STEP, IGES, or STL file. This can be produced by, I would say, all of the CAD software currently available on the market, and it is also possible to interact with multiple unit systems, such as International One or Imperial. In the mesh phase, Conself gives access to two types of algorithms, hexahedral and tetrahedral algorithm, both provided with boundary layer for wall refinement. And by using this, we can guarantee a correct wall resolution, and thus the correct value of the correct range for the Y+. Finally, we have the Conself features, in which we have multiple flow models available, such as incompressible flow and ideal gas, and turbulence models, among which is worthwhile noting K epsilon, K omega SST, and Spalar Talmaras. It is possible to run steady and transient simulation as well. I would like to mention that since we are using OpenFOAM, our results are well validated by the ENG group, which is the group that actually develops OpenFOAM. Conself obviously offers also post-processing features. It is possible to do most of the popular tools in post-processing, such as slices, trim slice, profiles, and contour plot. It is also possible to download screenshots in particular. I would like to mention that Conself, it is not just a CFD software. We offer support available online directly from the web application. Conself gives you access to a complete database of tutorials at wiki.conself.com, in which it is possible to actually see the documentation we saw in this webinar. We offer hardware resources available 24/7, and what is even more interesting, they are available on demand, so you don't need to book them. You can just run the simulation whenever you need. We also offer software development, particular on demand in case of particular needs. And what I would like also and proudly to announce is for the advanced user, we're about to release Conself, which is a customization of OpenFOAM we spoke earlier. This is going to be available on GitHub, and so stay focused on and follow us on GitHub in order to be up to date about this topic as well. I finished the presentation, so it's time to you now to make questions, and feel free to make any. Yeah, I'm getting the first question. That is quite obvious. Everyone is invited to use our web application available at the website www.conself.com. I would like to I'm asking sorry because I don't have time right now to show you the application, but for sure I invite you to visit our YouTube channel in order to see the many tutorial, the multiple tutorial we did in the previous webinars or in other appointments. Another question regards hardware resources. Well, in local computer, you don't need really hardware resources. Once you are able to provide us with a CAD file, and thus you need to have a CAD software, we can run the simulation also from a laptop and from iPads. Obviously, you could use also mobile phones, but I wouldn't recommend that because of the screen size in particular. The post-processing is rather difficult on mobiles, but theoretically, it works also on mobiles. One more question about internet connections, and in particular, whether someone needs to be connected in order to run the simulation. Well, you need one connection during the setup phase, and then the process, when you launch the simulation, the process runs in background, so you can log out of the application and just move somewhere else. Another company, probably regarding industries and companies, is it possible to share the results? Well, the answer is obviously yes. Conself is a web application, so you can create a company account, and by sharing username and password, you can allow multiple users to access the same subscription. At the same time, it is also possible for remote users, like people who are currently not in the head office of the company or in the technical office of the company, they can access it and actually view the results and what's going on in the setup phase. One more question regarding browsers and operating system. There is no limitation on the browser you can use. We tested the most popular browser such as Google Chrome, Mozilla Firefox, and Internet Explorer, and the application worked smoothly in all of them. It is obviously possible to use these browsers in any operating system, so Windows, Android, Unix ones such as Linux or macOS. While we wait for some more questions, I just remind you about our contacts. We are currently present in the most common socials, such as LinkedIn, Twitter in particular. Special mention for YouTube, in which we have a channel, a dedicated channel, in which we are going to upload all the documentation, such as videos coming from the webinars. So if you missed this webinar, log on our YouTube channel and you can see it. It's also important the email address on which you can contact us, which is info@conself.com. So by contacting it, you can ask us any information. Don't be shy, make us question. We are available almost every time. Oh, there is one more question about this application about pumps in particular. Some feature in particular talking about the erosion is not currently available on the application since it's just available for classical consultancy activity we do. And obviously we are about to release it probably actually. The next release, the 2.0, is planned by March 2016, and by that date, we are going to release the particular application for the erosion calculation. So in that particular moment, you can access also the erosion tools, as we saw it in this simulation. Last question probably is about the consulting activities. We are CFD experts. We have a consulting department in which you can just provide us with files and requests of design or engineering design, and we can provide a solution. Don't be shy. Get in contact with us. We are available. Just log in on our website and go to the consultancy section in order to know how we can help you. With this question, I think we can consider this particular web finished. I invite you once again to visit our website at www.conself.com. And I do thank you all for listening, and I expect you all using Conself application. Bye.